B was, if the ground shaft is replaced by a lathe turn shaft, what happens to the load carrying capacity? For which the value of H minimum is 3.75 for both shaft and the bearing, and so total value of H minimum comes out to be 7.5. Pressure was 3.8, right? So what was the load carrying capacity? Give me the answer. For 3.8, for 3.6 MPa, whatever the value of pressure you are getting. This one's done 11.4. kilonewton. So when H minimum was increased from 4.875 micrometers, the value of H minimum changed from 4.875 micrometers to 7.5 micrometers. The value of load carrying capacity changed from, or it rather decreased from 16.9 to 11.4. So what is the percentage reduction in the load carrying capacity? Give me the percentage reduction. Ambika, Vaishnavi, 32.5%. So this is the reduction in the load carrying capacity, which is 32.5%. So although we want the value of H minimum to be as high as possible to make it frictionless for effective dissipation of heat, but if you plot a graph of load carrying capacity versus H minimum, this comes out to be a hyperbola, wherein with the decrease in the value of H minimum, the load carrying capacity increases. As the value of H minimum goes up, the load carrying capacity would decrease. So this is what we have checked using this part of the problem. And in the second part, when the clearance is increased by 25%, what happens to H minimum by C? Assuming which value you want to assume, let it be 7.5. Let H minimum be 7.5. Give me the new value of C. Give me this ratio of H minimum by C. What was the previous value of C? 0.025. This was the value of C. Increase it by 25%. What is the new value of C? Give me the answers quickly. Point 03125. Which H minimum you want to take? 7.5? If we are going with this as H minimum, what is H minimum by C? Is that 0.24? And so what is the value of S, Sommerfeld number? From the graph, what is the value of S that you are getting? Point 0.05. Okay. So if S is 0.05, again give me what is the value of P, load carrying capacity, and give me what is the pressure and what is the load carrying capacity. The formula for Sommerfeld number, everything is known. Use new value of C, R remains the same, Z is same, N is same. What is the value of pressure P? Give me the value for pressure. Usual. .82. Somebody please confirm. Ujjwal is getting 2.82. Manas, Ambika, Tanvi.
Ma'am,
Yes.
ma'am, how to find the value of R in the formula of S?
Radius is given already.
So it will not change.
Radius is not changing. The clearance is increased, which means it's the inner surface of the bearing which is refurbished. So that dimension is increasing. Usually you got 2.82 with the same value of radius and diameter, right?
Yes, ma'am.
Okay. Harshil is getting 2.56. Give me load. Why others are not giving me the value for pressure? Manas, what is the value for average pressure? Manas, 0.56. If we go with 2.56, 2.57, give me what is the load carrying capacity? So pressure is reduced from 3.8 to 2.5. Load carrying capacity will also reduce from 11.4 to new value. Seven point six. Others, are you getting the same value? So the load carrying capacity has reduced from 11.4 kilonewtons to 7.68 kilonewtons. So you see that with 25% increase in the clearance, the weight reduces, the load carrying capacity reduces from 11.4 kilonewton to 7.68 kilonewton. You can find out in percentage, which means as long as the bearing is new, its load carrying capacity is good. The moment it becomes old and it is refurbished, this is still working. The friction is still low. It is working smoothly, but its load carrying capacity has reduced. So this is how we interpret the problem. Should we go for next? So quicker and faster you give me the answers, more numericals we can solve today. Next problem. A sliding contact bearing. A sliding contact bearing subjected to 5 kilonewton load has a shaft of diameter 60 mm running at 900 rpm. I'm repeating, a sliding contact bearing subjected to 5 kilonewton load has a shaft of 60 millimeters diameter running at 900 rpm. The square bearing, what do you mean by square bearing? What is the meaning of square bearing? L is equal to D, or L by D is 1. C by R ratio is given as 0.001. L by D is 1. If the ambient temperature, what is the ambient temperature at your places? Nagpur is 40, 41. Which place you belong to, Prajwal? Indore. What is the temperature there? 36. Okay. So ambient temperature here is 40 degrees. And same is there with other problem also. If the maximum allowable oil temperature is 85 degrees, suggest suitable oil. Suggest suitable oil, which means we have to suggest which SAE grade of oil is used, which also means we have to find out the value of Z viscosity. If it has to work, suggest suitable oil, if it has to work, without external cooling, with proper ventilation. So the meaning of this statement is amount of heat generated is equal to heat dissipated with well ventilation, with proper ventilation. So this will give us the value of coefficient of friction mu. Also determine whether it will work as a thick film lubrication zone. Whether it will work as thick film lubrication or hydrodynamic lubrication. So how do we check whether it is thick film lubrication? What is the criteria to check whether it is a boundary film, thin film or thick film? Which is the governing parameter? Vaishnavi? Zn by P? No. Which parameter talks about the film thickness?
Ma'am, viscosity, maybe.
No. It is H minimum. H minimum will decide whether it is thick film or thin film. So we have to find out H minimum, and in the design data book, we'll get a range of H minimum which will decide. Yeah, so it's the minimum distance between two. So it is H minimum. Let us solve this problem. So first is we have to get the oil, which means we have to get the value of Z. And for getting the value of Z, we must get Sommerfeld number somewhere so that we get the value of S. And we have to refer to some graph depending upon whatever parameters we have. If we have W known, we also have P because L by D is known. R by C or C by R is known. This is also known. So this is a condition which says that this can work with well ventilation. So we'll be using H. Heat dissipated is greater than or equal to heat generated. So heat dissipated is the value of K for well ventilation, area is L into D, temperature of bearing minus temperature of oil, ambient temperature plus 18 degrees. This is equal to mu W V, where V is pi dN. So from oil temperature and ambient temperature, you know how to get the value of TB. This is given in the data book. Give me the value for mu, coefficient of friction. Give me the value of TB first. What is TB? Shivesh, Sushmita, are you there? Yash? Anshuman, give me the answers. TB is temperature of the bearing is 62.5. Give me the value of mu. Deepika, what is the value for mu? Prateek, are you there? Prateek, mu is 0.00153. This is correct. Okay, so with mu now we can refer to the graph between Sommerfield number versus mu R by C, which is given on page number 13.3, figure 13.3, page number 134. I must write down this page number and figure number every time, so it's easier for you to check the values. This is the graph between mu r by c along y-axis and Sommerfeld number along x-axis. Check for L by D 1. So what is the value of S you are getting? What is S? 0.02? 0? Yeah, Sommerfeld number is a dimensionless number which has so many graphs that are plotted for Sommerfeld number versus H minimum by C, Sommerfeld number versus the ratio of pressure, Sommerfeld number versus mu r by C, and Sommerfeld number is one number which will help us get the value of Z, N, P, R, and C, these 5 variables. And these graphs are all obtained by performing number of experiments by two researchers, Raimondi and Boyd. So instead of doing the calculations every time, all the designers are expected to refer to these experimental graphs and curves. So Sommerfeld number doesn't represent something. It is just number of variables clubbed together to make it dimensionless. And the significance is only to get the variables that are required for designing a bearing. Okay, yeah. So S is 0.02 or 0.03. What are you getting? What is your mu r by C? 0.03. What is mu r by C? 1.5. So for mu r by C 1.5, your graph starts from 0, midpoint is 1, between 1 and 2 this is 1.5, and for L by D 1, it has to be 0.03. For mu r by C 1.5. So you are getting this as 3 into 10 raised to minus 2 from the graph. N is known, P is known, R and C are known. So give me the value of Z. So Ameya, do you agree it is not 0.02, it is 0.03? Okay. Give me the value for Z. 0.00184 value of Z. Somebody please confirm. 2.76 seems to be correct. Here 0.00276. This seems to be correct. This is 0.00276 or 277 Pascal second. Our graph of Z versus temperature, this is in millipascal second, so we can write down this as 2.7677 millipascal second. Now you can refer to the graph on the same page 134, figure 13.2. Give me the oil. For 85 degrees, maximum oil temperature, the value of Z around 2.76. Which oil is suggested? This is having a very low value of viscosity. What does your graph suggest? For such a low viscosity, light turbine oil. For such a low value of viscosity, the oil is light turbine oil. Now we have to check whether this is working as a thick film lubrication or whether it is satisfying the hydrodynamic lubrication condition, for which we want to get H minimum. How do you get H minimum now? How to find H minimum, Kaustubh? For L by D known, we'll refer the graph of H minimum by C versus sum of wheel number. The graph given on page number 136, figure 15.5. S is 0.03, L by D is 1. What is H minimum by C? Point 0.15, 0.16. What do you want me to take? 0.15, 0.16? Both are correct. Okay, let's go with 0.16. H minimum by C is 0.16. So what is H minimum? R by C is known. R is known. Give me what is H minimum. Give me H minimum. 0.048. This is in mm, right? Now whether this is termed as thick film lubrication or not, so we'll refer to page number 130, design data book, table 13.5. What is the first point given here for a hydrodynamic lubrication? What does this table suggest? What is the minimum value of H minimum given there? Is it 0.048 you are getting or 0.0048? Yeah, it is 0.0048. One decimal is missing. 0.48 बहुत ज़्यादा हो गया. Yeah, you are right. It is 0.0048. So what is the minimum value for H minimum as per this table? For finely bored bush or brasses and polished shaft, minimum value has to be 0.0025, which means H minimum should be greater than this. Desirable is 0.0050. So if our H minimum is in this range, greater than this, around this is a hydrodynamic lubrication. So we are getting quite close to 0.005. So this is very much satisfying hydrodynamic lubrication. You must write down this satisfies hydrodynamic lubrication case. This is hydrodynamic lubrication, assuming it is finally bored bush and polished shaft. So your journal is polished. So that is telling you about the surface finish. And the bush or the inner surface of the bearing. This is bored. And this is bored with a very fine surface finish. That is the meaning of this. And the second one is saying if it's a Babbitt bearing and a polished shaft and rotating at high speed, then H minimum should be 0.002. If it is rotating at low speed, H minimum should be 0.004. So our value of H minimum is lying in this range. So we will put a comment that this is a case of hydrodynamic lubrication, assuming the bush is the covering of the shaft, that is known as a bush. So here it is the inner surface of the bearing, which is bored with a very fine surface finish, and the shaft is polished. Is that clear? If yes, then we go for next problem of different type. Depending upon the type of machinery, we have the type of bearing, bearing pressure, minimum value of Zn by P. So we'll solve one problem of this type. So if there are no doubts, I'm going for the next question. So no doubts, no questions till here. Vaishnavi, Prajwal, Daitwa. Okay. So next problem, a shaft of a centrifugal pump. Shaft of a centrifugal pump is rotating at 600 RPM and is supported by a bearing 50 mm diameter. The bearing is subjected to a load of 3 kilonewton. Suggest suitable oil. Suggest suitable oil if it has to run hydrodynamically. The condition is it has to run hydrodynamically with the oil temperature not to exceed 85 degrees. Not to exceed 85 degrees Celsius. Okay, let us try to solve this problem from a different approach. Page number 128, 129. Refer table 13.4. Do you see the details for centrifugal pump? What should be the bearing pressure? What should be the viscosity? Minimum value of Zn by P, C by R, L by D. Could you locate centrifugal pump? Manas? Ujjwal? Say yes, no, something.
Yes, ma'am.
Okay. Okay. So what is the range of pressure given for centrifugal pump? What is the pressure range? 0.7 to 1.4. What is the value of Z given? Viscosity 25 MPa millipascal second. What is the minimum value of Zn by P given? This is given as 46. C by R is given, L by D ratio is given. So you have to select a ratio between 1 to 2. Similarly, the maximum value of pressure versus velocity, this range is given. So we'll be referring some of this data for solving this problem. So what is L by D now? You want to assume it is given between range of 1 to 2. Let's go with 1.2, which is the default value for making it standardized for all the students. If we assume L by D as 1.2, where D is given as 50 mm. So L is becomes 60 mm. For a load of 3 kilonewton, let's check if the pressure is lying as in this range. This is the data for hydrodynamic lubrication. If L by D is taken as 1.2, are we getting the pressure in this range? If not, then you have to change L by D so that you get it in this range. Are you getting 1 MPa? Okay, so which is very much in this range. So this L by D is correct. Next, we have to find out Zn by P, which will give us the value of Sommerfeld number S. Now this is the minimum value of Zn by P, and if you remember, there was a curve of Zn by P versus other parameters. How with Zn by P, the value of other parameters, they are changing. And I told you that the actual value of Zn by P should be little greater than its minimum value. And how much it should be greater than the minimum value? Because that will give you its stability. It was there in those slides. So the actual value of Zn by P should be greater than the minimum value of Zn by P. By what amount it should be greater than minimum value? 5 to 10 times. Perfect. So we have to take some value in this range. You can take it 6 times, you can take it 7 times, you can take it 5 times. So when you increase the actual value of Zn by P with continuous operation, as the oil temperature increases, the value of viscosity would go down, and it again tends to come back to its lower value. So likewise, when we take a zone of Zn by P, which is say 5 times or 10 times or in this range greater than the minimum value, you are in a stable zone. So should we take it 6 times? You can take any value between 5 to 10. You can take 7 times, 8 times. So let us take it 6 times of the minimum value, which comes out to be how much? Minimum is 46. $276. C by R is known, which means R by C is also known for centrifugal pumps. And if Zn by P and R by C is known, you know what is S. Zn by P into R by C whole square. Give me the value of Sommerfeld number here. Convert into appropriate units. If you are taking S as 1.5, no, we are taking this as actual. If you are taking Z in millipascal second, and if your pressure is in megapascals, then your value of S would be Zn by P. This is also given in the data book. R by C whole square 10 raised to minus 9. Yeah, it is 0.276. This is correct. How did you got 1.5? Here we missed oil. So if Zn by P is 276, what is Z? We have to suggest oil. For Zn by P 276, N in RPS, P in MPa. Z is 27.6, which is close to the value that is given in the design data book. Suitable viscosity is given as 25. We are getting 27.6. So what is the oil? The temperature is not to exceed 85 degrees. Refer the graph. Give me the oil. For 85 degrees, 27.6. Ujjwal, which oil? Correct, SAE 60. So this also gives you a fair idea of what is the meaning of SAE 60 or what is the meaning of SAE 10. So how the viscosity for SAE 60 is in the range of 30 MPa or millipascal second, or a light turbine oil is oil with very low viscosity, less than 10 millipascal second. Okay, so moving back from the sum of the number, we have to again check if this is running hydrodynamically. So for L by D, that we have assumed as 1.2. For S, 0.276. For hydrodynamic condition, we have to find out what is H minimum. So again, from the graph, for this value of S, give me what is H minimum by C. We have to see that the value is greater than the minimum desirable value of 0.0025. This should be greater than 0.0025. So 0.276 is 2.7 10 raised to minus 1. L by D 1.2, you have to take close to 1, between 1 and 2. What is H minimum by C you are getting? 0.6. 0.65. Yeah, it should be somewhere between 0.6 and 0.7. So if H minimum by C is 0.65, multiply it with C and give me what is H minimum we are getting. Is that greater than 0.0025? So it's almost 4. I wanted to take 2 more numericals related to this. What is H minimum you are getting? Point 0.016 or 0.0016? 0.0016. and is coming out to be less than this value of H minimum. Yes, so it is not hydrodynamic. We have to increase H minimum by C, for which what can be done? If you want a higher value of H minimum by C, what you need to change from the graph? L by D, yes. So if you change the L by D to say 2, or if you make it 1.8, your H minimum by C, this will, if you go with 1.8, your H minimum by C will come out to be 0.7, 0.75. Please check for what value of L by D you are getting H minimum greater than 0.0025. If we change, this is not a case of hydrodynamic lubrication. What is the value of L by D you are trying now? Say 1.8. L by D 1.8. What is your question, Ayush? H minimum by C greater than what? Yeah, we have to make sure that this is running hydrodynamically. It is in the graph with L by D 1.8, with S value 0.276, it is 2.710 raised to minus 1. Now your H minimum by C will be around 0.76, 0.77. Isn't it? Ayush? For L by D 1.8, what is H minimum you are getting? P is becoming how much? 0.67. So go with 1.7, 1.6. So we have to iterate for different value of L by D because that is the only thing that we have assumed. And the range for L by D is given as 1 to 2. What if you take L by D as 1.5? You can use H minimum 0.0025. Find out what is H minimum by C, and accordingly you can go with L by D. That you can do for 1.5 or for 1.6. Check H minimum, which should be greater than the minimum value. Check pressure, it should lie in that same range. Shravya, you are there? Shravya? Ujjwal? Give me the answer. Prajwal? Ameya? Point 01625. This is what? This is H minimum. You are saying 0.001625 or 0.01625?
Ma'am, the
Yes.
calculated value is coming 0.01625, not 00 there.
For H minimum?
Yes, ma'am. Previous one.
So this is much higher. So this is not the 0.006. Then this is much higher than H minimum. It is higher than desirable also. So higher value of H minimum is always good. So if you are getting this value as 0.016, this is definitely greater than this minimum value, and this is a hydrodynamic case. You don't need to worry about L by D and P then. Please check if this is 0.016, this is greater than 0.0025, and so this is a case of hydrodynamic lubrication. So this completes our sliding contact bearing. Next week we are going to start with the rolling contact bearing, and I'm looking forward to teach you in a physical mode from next week. Hope you will be attending the lectures in good number. So if it's 100 plus student, then we can have it in physical mode. The number of students coming to the class is only 25 and 30. Getting it in a hybrid mode is, I don't know how much it is possible. We'll have an online class then. Yes, wire rope design is there in our syllabus. We are left with rolling contact bearing, wire rope design, and then the assembly problems. So if you have any doubts in whatever questions we have solved till now, hydrostatic bearing is when one of the surfaces is stationary and the two parts are separated each other. It's load bearing, but then there is no relative velocity. So we say it is hydrostatic bearing. Definitely not used in. So assuming the shaft is not rotating, but it is taking care of the weights. And we don't call that part as shaft because shaft is a rotating member. So if a member which is carrying load and it has to be supported at the ends, we use hydrostatic bearing. Anything else? Any more doubts? Should we stop here? Ambika? Shriya? Okay. Thank you. See you on Tuesday again.